So far in Chapter 2, we've discussed three ways to display numeric data: with a dot plot, with a histogram, or with a stem plot. In this video, we want to talk about the features of these displays that we can discuss. And there are three aspects we're going to focus on: the shape, the center, and spread. For the purposes of our class, shape will be described usually in one of these three ways. Either the display is symmetric, in this case it's bell-shaped or normal, a term that we'll use more frequently later on. Note that you've got your highest peak in the middle, and it walks its way down fairly equally on the left-hand side and the right-hand side. It does the same thing on both sides, therefore we say it is symmetric. Another way to describe the shape of a graph is skewed left. This is an example of a skewed left histogram. I know this is a histogram because the bars, the bins, they're touching, and I have numbers across the bottom. It's numeric data. And it is not symmetric. My highest peak is over here on the right-hand side. I have a tail on the left. Therefore, this is skewed left. The tail gives you the direction the graph is skewed. Our third way that we could describe a graph for this class would be skewed to the right. This histogram on the right-hand side is skewed to the right. I've got my highest peak on the left-hand side of the display, and I have this long tail on the right-hand side. It's skewed right. It's not symmetric. It's not walking its way down evenly on the left-hand side and the right-hand side, but there are way more bars to the right-hand side. It is skewed to the right. And this would be true for a dot plot as well. If you have a lot more dots to the right of the peak than to the left of the peak, it would be skewed to the right. If it doesn't fit one of these three shapes, either skewed right, skewed left, or symmetric, we'll say it has no shape for ease. The second aspect to focus on is the center. And the center is going to come up again in Chapter 3, and we're going to be more in depth with its definition. But for now, the center is just the typical value in the data set. We're going to describe it as the highest peak in that distribution of our sample. Where were most of the values located around? If I look at this particular display, the highest peak right here in the middle. And so I would estimate my center to be around 13,000 seconds. Most of my observations, more than any other display bar here, were in this bar, this bin. So that's where my center is going to be. And it may not be exactly 13,000, so I said around. Again, we'll find a way to calculate this in a more precise way in the next chapter, Chapter 3. And that's also true with this final characteristic, the spread. The spread can be known as the variability of our data set. Spread and variability I'll use interchangeably. But we want to consider the amount of variation in our data set. We're going to refine this more, but we say the data set has lower variability if the distribution is narrower with the values closer together. And the data set has a higher variability or a higher spread when the distribution is wider with values farther apart. And these displays below illustrate a lower variability, lower spread, and a higher variability or a higher spread. This first graph shows a family of 4 people who all have heights around 70 inches. It appears maybe it's 68 inches to 72 inches. So all 4 are between, just estimating, 68 inches to 72 inches. Those 4 family members are very close together in height. It would have a low spread. The data isn't very spread out. In this second display, this second family, we have a higher spread because we have the first family member who's about 45 inches tall. That's just under 4 feet tall. The next family member is 55 inches tall. The third family member is 65 inches tall. And then the fourth and final family member is 75 inches tall. That's 6 foot 3 inches. Again, the shorter family member, they're 3 foot 9. So we see this data is very spread out. If it's all clustered toward one spot in the middle, it's lower spread, lower variability. If it's very spread out, and we've got gaps in our histogram here, we have a higher spread or a higher variability. For now, we're going to say higher or lower, so we really need to have 2 displays to compare. We'll talk about a numeric way to describe spread in Chapter 3. Just one quick example to wrap up these characteristics. I want to describe the center and the shape of this particular histogram. The center and the shape. I don't want to describe the spread because I don't have another histogram to compare it to. Is it more spread out or less spread out? But the center, for now we're saying it's the typical value. It's where the highest peak is. So I have the number of piercings someone has, 0 all the way up to 10 at the max, and the frequency, the number of times we saw that result. So the center would be at 0. 0 piercings is typical from this sample. That's where most people fell. And for the shape, here's my highest peak on the left-hand side, and if I just sort of trace over the top, I'm drawing out a long tail to the right-hand side. This would be skewed right. I've got my center at 0. I've got my shape as skewed right.